Today we're going to talk about algebraic expressions. Here are some new vocabulary terms for you. The first one is term. It's the different parts of an algebraic expression. For example, 3x, or 5x squared, or 9xy. Like terms are terms that contain the same variables to the same power. So for example, 5y squared and 10y squared both have a y squared. Coefficient is the numerical part of the term that contains a variable. So for example, if we have 6x squared, the 6 that's in front, that would be called the coefficient. And lastly, constant. A constant is just a term without a variable. So for example, like the number 7 or like the number 10. Here are a list of some algebraic terms. See if you can decide which ones are like terms, which ones go together. Remember, like terms are terms that have the same exact variables. So if I picked out a couple like terms, I would say that 15y and 7y are like terms. The 9z squared and the 33zz, those would be considered like terms because they both have z squared with them. Next, I would say 5x and 12x. They have the same exact variables. Next, we could point out the 10 and the 4. We do have a term that's left over, 23xy. That's not going to match up with anything else because there isn't any other number that has an xy attached to it. Alright, so there are two parts to every term. You have a number part and then a variable part. The number part, just like in your vocabulary words, that is called the coefficient. The variable part is called the variable. The only type of term that doesn't have two parts are terms that are constants. That would be the number 10 and the number 4 in our list. Alright, so now let's go ahead and start simplifying algebraic expressions by doing what we call combining like terms. Now, I like to use circles, squares, hearts, underlines. You can use different color highlighters to do this part. But what we want to do is we want to look at an expression and then combine all of the terms that are considered like terms. So for example, in number 1, we have 9x plus 5x. Now, if we look for terms that have the same variable, we have a 9x, and then we have a plus 5x. You want to circle the sign that's in front of the term because that tells you if it's positive or negative. So now if I take 9x plus 5x, I get 14x. And that's as far as I go because I don't know what x is actually equal to. Next, we have number 2. We have 20a minus 14a. Since they both have an a attached to them, we can just go ahead and subtract, and we get 6a. Number 3 looks a little more complicated. We have some different terms this time. So we have 10x would be matched up with the plus 3x, and it would also go with the minus 2x. Then we have a couple terms with y's. We have plus 7y and another plus 7y. So now when we combine these terms, if you notice what's in the green circles, we have 10x plus 3x minus 2x. So 10x plus 3x, that's 13x, and then 13x minus 2x is 11x. Now we go to what's in the blue rectangles. We have positive 7y plus 7y, which would be plus 14y. So our answer, the simplified expression, is 11x plus 14y. We can't take it any farther because one has an x and one has a y. All right, and lastly, number 4, let's go ahead and circle our like terms. We have a 2x. It doesn't look like that matches up with anything, so I'm going to leave that one alone. The minus 4y, again, doesn't match up with anything. However, we do have a plus 3z and a plus 17z. So that 2x minus 4y that's in the beginning, that one is just going to stay the same. But we are going to combine the 3z and the 17z to make 20z. And that's as far as I can go. That's your answer. All right, so now let's start solving or simplifying algebraic expressions by using the distributive property first. If you notice, we have parentheses in all three of these expressions, and our first job before we can do any combining is to use the distributive property to get rid of those parentheses. So if you remember the distributive property from the last lesson, we want to take 3 times a, which is 3a, bring down that plus sign, and then take 3 times 4, which is 12. And then anything that's left over in the expression we want to bring down. That would be the plus 6a. Now it's just like all of the problems we did earlier today. We're going to look for our like terms. It looks like we have a 3a and a plus 6a. Those would be like terms. And so therefore if we combine those, 3a plus 6a would be 9a. And then we have the plus 12 in the middle that doesn't match up with anything else, and so that would be our answer. Okay, number 6. Again, we're going to start with the distributive property. 6 times x is 6x. Bring down the plus sign. 6 times y is 6y. And then we have minus x and plus 4y. Now let's go through and look for our like terms. We have a 6x and a minus x. And then we also have a plus 6y and a plus 4y. If we first combine what we circled, we have 6x minus 1x, which is 5x. And then 6y plus 4y is positive 10y. Okay, and the last one, number 7. First, we have to do the distributive property. If you notice on this one, though, there is a minus sign that's in front of that 2. And so we're not just distributing a positive 2, we're actually going to distribute a negative 2 this time. So negative 2 times y is negative 2y. Bring down your plus sign. And then negative 2 times 2 is negative 4. Now, there's a bunch of stuff we haven't used yet, so let's bring down the 9, bring down the plus sign, and the 4y. And now we're going to go through and look for our like terms. And then we have some constants. So we can go ahead and combine them. 4y minus 2y is 2y. And then 9 plus negative 4 is positive 5. Okay, now it's your turn. Go ahead and pause the video, try the following problems on your own, and then play the video to check your answers. All right, so go ahead and take a look at numbers 8 and 9. See if you solved those two correctly. One thing I do want to point out about number 9 is you may have noticed that there is a negative x in the front. Remember that if it's just negative x, that means negative 1x. For number 10, it's really important to see that that 5 has a negative sign in front of it, so when we distribute, we're supposed to be distributing negative 5. So we end up with negative 5y plus negative 5 for this last part. And then if we bring everything else down and then start circling what we have in common, it looks like we have a 10y minus 5y, which is 5y. And then a positive 2 plus negative 5 is a negative 3. So you can either write plus negative 3 or you can write 5y minus 3. That would be the same thing. Now, same thing happens in number 11 where you have to distribute this negative 2. So if you did not do that and you just distributed positive 2, go ahead and pause the video and fix it and see if you can get the correct answer once it's fixed. All right, let's see if you were able to get it. So negative 2a, we'd bring down this minus sign, and then negative 2 times 7 is negative 14. We do have a bloop bloop right here, so we're going to fix that. And now we look for our like terms. So we have 8a minus 2a, which is 6a, and then the plus 14 at the end. And then lastly, the last problem, if we distribute this 2 here, we'd end up with 6x squared minus 12. And then in front, now we take a look at what we can combine, and actually in this one we don't have anything we can combine because the x term and the x squared term can't go together because they don't have the same exact variables. Let's go ahead and apply a little bit of what we learned. Write an algebraic expression for the perimeter of the following shape. And then what's the perimeter if x is equal to 5 and y is equal to 7? Well, in order to write an algebraic expression for this, we need to add up all the sides because that's how you find the perimeter of the shape. And so our expression would be 4x plus 3y plus 4x plus 3y. So that would be our original expression. We can combine some like terms if that would make it a little bit simpler. So like 4x plus 4x would be 8x, and then we'd have 3y plus 3y, which is 6y. Now the second part of the question says, what is the perimeter if x is equal to 5 and y is equal to 7? So if we plug in 5 for x, and then 7 for y, if we solve this, this will tell us the perimeter. So we end up with 40 plus 42. So our final answer is 82. See if you can write an expression for this next problem. You bought 5 folders that cost X dollars each, a calculator for $45, and a set of pens for $3. Write an expression in simplest form that represents the total amount in this situation. Now, if you're not sure where to start, if you think about it, we are buying 3 different items. So we know that we're going to have to add our 3 items together. We bought 5 folders, and each folder cost X dollars. We also bought a calculator, which was $45, and we bought a set of pens for $3. So now if we take this and simplify it, we can combine our constants, and our answer would be 5x plus 48. Go ahead and try number 12 on your own, and then play the video to check your answer. All right, let's see how you did. You bought 3 snacks that cost Y dollars each, plates for $1.79, and a drink for $2.19. Hopefully you combined your like terms here. So then our final answer, once we simplify, it's going to be 3y plus $3.98. Nice job.